Hello, ma'am.
Hello.
Hello, ma'am. Yes, ma'am.
Okay. So we were discussing in last class chemical bonding, right?
Yes, ma'am.
What was it called? MOT.
Yes, ma'am. MOT. Hydrogen bonding will. We need to start hydrogen bonding.
We need to start hydrogen bonding. You want me to explain it through notes or from book?
Ma'am, what, ma'am?
You want me to present the book or write on the notes? What's your preference?
Not writing on note will be better.
Oh, you can continue on the notes. Give me a second. Do you have checked the classes or no, Himansh?
Ma'am, today I will check. Ma'am, I will not check. After class, I will message in 10 minutes.
You did that questions or no? Of the previous part? Practice it.
I'm still doing.
You're doing that.
Yes, ma'am.
So hydrogen bonding means what people say hydrogen bonding. When hydrogen is bonded to atom of higher electronegativity, like chlorine, oxygen, nitrogen. So hydrogen atom form a weak bond with electronegative atom with another molecule, negative atom. So we can say, let's say this is HX. So this hydrogen will make a weak bond with the electronegative atom of the another molecule. This weak bond is known as hydrogen bond. So hydrogen contain partial positive, X contain partial negative. Hydrogen contain partial positive, X contain partial negative. So accordingly we can say there is a weak bond in between them, that is the hydrogen bond. Got it or not? Yes, right? FF molecule. So in them there is partial bonding like this, that is hydrogen bonding. Right? We can say in other words, hydrogen atom act as a bridge between the two atoms. to atom. Got it?
Yes, ma'am, got it.
Like how can it act as a pre atom? One bond, one covalent bond, and by one covalent bond by one atom, and other atom through, we can say, hydrogen bond. Other atom through hydrogen bond. Okay, hydrogen bond represented by this dotted lines like this. Okay, so if we want to define the hydrogen bonding, how to define hydrogen bonding? So the attractive force which bind hydrogen atom of one molecule with electronegative atom. Like chlorine, oxygen, nitrogen of other molecule is called hydrogen bond or hydrogen bonding. Okay, got it?
Ma'am, only fluorine, oxygen, and nitrogen only.
Exactly. Okay. Strength of bond is strength of hydrogen bond. It's very low compared to ionic bond, compared to covalent bond. So the range over here is constant 10 to 40 kilojoule per mole, while for covalent is 400 kilojoule per mole. So we can say hydrogen bond is 1/10 of strength of covalent bond. Okay. Bond length. Obviously, if bond strength is less, bond length will be high. Hydrogen bond is more than covalent bond. For example, in HF, hydrogen bond is having the bond length of 1.55 picometer, 155 picometer, while over here it is 109 picometer. Okay. What is the cause of hydrogen bond? Causes of hydrogen bond. The cause is due to formation of, we can say, partial charges. Electron displacement. Okay, partial electron displacement. We can say element got partial charge. And there is bond correlation, right? Like HA partial positive, partial negative. Another HA partial positive, partial negative. The positive and negative are attracting each other. Partial positive, partial negative. Partial positive, partial negative. Alright, Himansh.
Yes, ma'am.
Any questions for hydrogen bonding condition? Like when we can say hydrogen bonding can happen. First is high electronegativity of atom. high electronegativity of atom bonded to hydrogen. Right? Like fluorine, oxygen, nitrogen. Example, HF, H2O, NH3. Small size of electronegative atom.
And because this small size of electronegative atom can polarize the electron cloud, that's the reason.
Polarity in bond between hydrogen and electronegative atom. Right? For example, NH3 show hydrogen bonding, but HCl not show. Although electronegativity is same. Electronegativity of nitrogen is equals to electronegativity of fluorine, which is 3. Why is it like chlorine is having big size and nitrogen is having small size? So more polarity and over it is less polarity. Got it?
Yes, ma'am.
Okay. Any problem, Imanj?
No problem, ma'am.
Now is the difference between hydrogen bond and covalent bond. Hydrogen bond and covalent bond. So hydrogen bond involve dipole-dipole interaction. Dipole-dipole interaction. Covalent involve sharing of electrons. Here, hydrogen atom and electronegative atom. Highly electronegative atom like fluorine, oxygen and nitrogen, which we can form between any two electronegative atoms. Which may be same or different length. Strength of hydrogen bond is very small. And here is bond strength is high. Okay. Example, HH bond hydrogen 433 kilojoule per mole and HF 41.83 kilojoule per mole. Okay. Any problem, Imanj?
No problem, ma'am.
Example of hydrogen bonding compound. You want me to show? Okay, sure. Okay, let's. Example, hydrogen bonded compound. First is hydrogen, right? So in HF, how the structure actually exists is the zigzag-like manner. That's okay. So there is zigzag chain of molecules. So it is like HFN. In liquid or gaseous state, na, the chain become linear. Next example is water. The water forms structure to be like oxygen having hydrogen. Next atom contains again oxygen, hydrogen and hydrogen. Now oxygen and hydrogen are bonded to hydrogen bond. This oxygen and hydrogen is bonded to hydrogen bond, oxygen, hydrogen. Again it will be bonded to hydrogen. Are you getting it? Like how I'm drawing it. Oxygen, hydrogen. They're forming like this cage-like structure. Got it? So it's H2O. So we can say each oxygen is tetrahedrally surrounded by 4 hydrogen. 2 by covalent and other 2 by hydrogen bond.
Why only two maximum hydrogen bonds are formed?
There is we can say space arrangement, that how many atoms can arrange around it, how many vacancies that, right? Also oxygen contains 2 lone pairs, so that will show the affinity to bind with others. This man.
Because of two lone pairs, it's only can attack two gas.
Third is NH3, ammonia. Ammonia has electronegative nitrogen atom bonded to one hydrogen, second hydrogen, third hydrogen. Partial negative, partial positive. This is also partial positive and this is also partial positive. So there is kind of getting it or not?
Yes, ma'am, getting.
And the types of hydrogen bond. So we can divide it into 2 types. Intermolecular hydrogen bond and intramolecular. First of all, discuss about intermolecular. In between the molecules, right now we'll discuss intermolecular only. right? So hydrogen bond formed between two different molecules of same or a different substance. Got it? Himansh.
Yes, ma'am, got it.
So, to say hydrogen molecule example, we did discuss H2O, NH3, HF, all of them were intermolecular in between the two molecules. So, hydrogen bonding result into it increases the melting point, boiling point, viscosity, surface tension, and solubility. Okay. By melting point, because two molecules are now bonded strongly with each other. Boiling point will also increase because molecules are bonded strongly. Viscosity, because molecules are consistently packed, so their viscosity means how much viscous the liquid is, it will be reduced. Surface tension again will increase because surface tension makes the particles adhere, or we can say how particles are bonded, so they will increase the surface tension and solubility ultimately, because if molecules are forming the bond with other molecules, they will easily be soluble in each other, right?
Yes, ma'am.
And another one is intermolecular hydrogen. Intramolecular. Intramolecular hydrogen bonding. We have hydrogen atom and highlight electronegative present in the same molecule. Bond is formed between hydrogen atom and highly electronegative atom. Highly electronegative atom, chlorine, oxygen, nitrogen, that is present in the same molecule. Okay. So it result into the cyclization, because if intramolecular is there, na, the result in the cyclization of a molecule, in cyclization of molecule and prevent their association. Association means it will not combine with other molecule, no? So we can say the effect of this in physical properties is very less. Very negligible, we can say. Example, we can take an example of orthonitrophenol. So this is OH, OH and NO2, NO2. So oxygen and hydrogen will bond it to each other with the help of this hydrogen bond, and this hydrogen bond is intramolecular. Orthonitro-benzoic acid also contain an example of it. Orthonitro-benzoic acid. So C O OH nitro be like this. Got it? Dimansh. Ortho, hydro, benzoic acid, ortho, nitro, phenol. Got it? Any problem, Dimansh, as of now?
No problem.
Next, discussing about influence of hydrogen bonding on the properties. On the properties. Influence of hydrogen bonding on the properties. First is association. What is the meaning of association? See, two molecules combine with each other and exist as associated molecules. Correct, no, Himansh?
Yes, ma'am.
For example, carboxylic acid. R C O O H. R C O O H. So here there is formation of this hydrogen bond. So result is molecular mass increases, size of compound increases. Got it?
Yes, ma'am. Got it.
Yes, Himansh. Himansh, can you hear me?
Yes, ma'am. Hello, ma'am. Yes, ma'am. You are audible, ma'am. Hello, ma'am. Hello, ma'am.
Yeah, now you are audible.
Yes.
Higher melting point and boiling point. And boiling point. So what we can say for it? Melting point and boiling point. electrostatic force of attraction between the molecule due to hydrogen bonding. But we can see electrostatic force of attraction increase. Correct, Naimansh?
Yes, ma'am, correct.
If they increases, so we can say large amount of energy is required to break them. So melting point and boiling point will. Got it?
Yes, ma'am, got it, ma'am.
Give me a second. There is certain plots as well, I guess. Plot is also there, right?
Yes, ma'am.
Melting point and boiling point increase as the molecular mass increase. So in group number 14, melting point and boiling point increase as the molecular mass increases due to size of the atom. As the size increases, reason is that if the size increases, number of electrons increases. As the result, van der Waals forces also increase. Van der Waals force also increase. And melting point, boiling point increase. Got it or not?
Yes, ma'am, got it, ma'am.
But hydrides of, this is for group 14, but group 15, 16, 17, not show this spread. In group number 14 elements now, we can see this thing, but hydrides of group 15, 16 and 17 do not show this trend. In these flows, what actually happens, melting and boiling point also increase with increasing a molecular mass. But exception, first member. First member, example, NH3, H2O, HF. Abnormal high, they are having abnormal high melting point, then boiling point, due to the reason of hydrogen bond. Okay? Got it or no?
I got it.
Now, a very interesting note point is that hydrogen bonding, we can say hydrogen bond strength HF is greater than H2, but till then, water boil at higher temperature than HF. Okay, and there is a we can say interesting point to note that reason is H2O molecule bonded to 4 other H2O molecules.
Google storage కోసం
Bonded to 4 other H2O, isn't that?
చెప్పాలి ఏంటి అది
Through hydrogen
గూగుల్
bond.
ప్లే స్టోర్ కట్టింది అంతే కదా నిన్నే
But one
అంతే కదా
HF bonded to 2 other HF. through hydrogen. Okay.
इसमें हम
Third point, her influence. Influence on physical state. Influence of physical state. So hydrogen bond also influence the physical state. Solid liquid gas. Example: oxygen and sulfur. H2O oxygen, H2S sulfur. So H2O is liquid at room temperature, but H2S is gas at room temperature. Okay. So the reason is
आपके सामान
that due to H2O, electronegativity of oxygen is high, and here electronegativity of sulfur is low. Oxygen electronegativity value is 3.5 and sulfur electronegativity value is 2.5. For hydrogen, electronegativity value of hydrogen is 2.1 and hydrogen electronegativity value is 2.1. So there is little difference in electronegativity, so we can say no hydrogen bonding is existing. Okay. So here hydrogen bonding happen, but here not. So that is the reason their atoms are more closely packed and it exists in liquid at room temperature. Got it? Fourth one is, fourth factor is solubility. Solubility. Hydrogen bonding influences the solubility of one substance in other. Example: alcohol is highly soluble in water. Reason is hydrogen bonding. How can we show that? ROH, HOH, ROH, HOH. So here we can see this hydrogen bonding in between. Okay, it is alcohol, water, alcohol, water. Fifth factor is, or any doubt as of now? Manch?
No doubt.
Next is volatility. Fifth factor is volatility. So we can say compound volatility is inversely proportional to hydrogen bonding. If the compound contain hydrogen bonding, volatility is low. Example: we can say NH3, H2. They are having high boiling point. They are less volatile. Okay. So enthalpy of vaporization is related by enthalpy of vaporization. Okay, can you tell me enthalpy of vaporization increases or decreases with hydrogen bonding? What's it?
It will increase now.
Okay.
Yes, ma'am.
Because their masses are also varying, na? That is why this unusual trend we are observing. See, basically on moving from top to bottom, enthalpy of vaporization increases, but due to abnormality, from moving from top to bottom, enthalpy of vaporization increases, but due to hydrogen bonding, first member have high enthalpy of vaporization. Got it now? pH SpH3 but NH3. Okay, so that is the reason if we do talk about orthonitrophenol and paranitrophenol. Orthonitrophenol contain hydrogen bonding which is intramolecular hydrogen bonding. Orthonitrophenol and paranitrophenol. The orthonitrophenol exists like OH, NO2, and paranitrophenol exists like so. Here we can say so here is intramolecular and here it is intramolecular. Due to this is intramolecular and intramolecular, so we can say less volatile, more boiling point. It is even steam volatile. It is even steam volatile, having less boiling point. Is that clear or no?
Clear now.
So now the next topic is water is an unusual liquid. Water an unusual liquid. So water is most common substance on Earth's surface. It is having unusual properties. So one such unusual property is its ability to dissolve a variety of compounds. A variety of compound means ionic, polar, organic or inorganic, polar organic or inorganic substances. Right? It's having high heat of vaporization. Next is high heat of fusion. High specific heat. Good liquid range. Means that from 0 degree freezing point to 100 degree boiling point. So not that much varying, na? Otherwise some of the substances are having a very wide freezing and boiling point range. Okay. So if we do discuss about hydrogen bonding in water and ice. So let's discuss about it. Hydrogen bonding in water and ice. So density of ice is less than that of water because ice floats on water, right? Density of water is maximum. Density of water is maximum at 4 degrees Celsius. Right or no?
Yes, ma'am.
So tetrahedral arrangement of water molecule is like oxygen, hydrogen, oxygen, and okay, this is how actually the structure of it exists to be like. Okay, any problem, any doubt?
No doubt.
Now the point is that ice is lighter than water. Ice is lighter than water. We have already drawn the structure of water molecule. Like this. I hope you are getting it or no? Mensch. Then how am I going to structure of it? So kind of a cage-like structure you can see of it. So these are the vacant spaces. These are the vacant spaces. Okay, so open cage-like structure of ice exists. Open cage-like structure. So as a result, tetrahedral arrangement of, so it is a kind of seems to be like a planar structure, but actually it is a tetrahedron. Okay, oxygen atom of water molecules are located at the oxygen atom are at corners of tetrahedron. So it's a 3D structure. Okay. So there is a large vacant spaces. Large vacant space are there. So volume is high. Volume high, so density is ultimately low. Got it, Himansh? Huh? Himansh?
Yes, ma'am, got it.
Last topic of this chapter, the water has maximum density at 4 degrees Celsius. Density at 4 degrees Celsius. This is the last thing remaining. So when ice is melted by increasing its temperature, then ice melt by temperature increase. Open gate structure start collapsing. Open cage structure start collapsing. Right? Water come close. Okay. So if they come close, it result in volume contract. Volume decreases. The density will start increases. Okay, maximum at 4 degrees Celsius will reach maximum at 4 degrees Celsius. But now, if temperature increase further, what will happen? Kinetic energy will increase. So kinetic energy move away. Density will again volume will increase, and if volume increase, so density will decrease. Density will decrease, so we can say again what will happen? Expansion. Okay.
Yes, ma'am, okay.
And your chapter is done. This chapter is completed. Now we need to do the another chapter, right?
Yes, ma'am.
So we can take another class at 2 o'clock. What's it? 2 o'clock?
Yes, ma'am, okay, ma'am.
We will start organic, or we will continue organic itself. Himansh, right?
Yes, ma'am, we'll continue on.
One thing, we will schedule 2 classes a day, right? Himansh, listen. 2 classes a day. See, in 1 hour, I believe that many of the things are covered. Isn't that 1 hour for one part, another 1 hour for another part? It is sufficient, correct or no, Himansh?
Yes, ma'am.
You can share your opinion as well, because yes, Himansh?
Yes, ma'am, it's sufficient.
So in 1 hour we will continue, because see, my speed is quite high in writing the portion for you. So I will write only for you, no issues. I will not present it from the book. I will write only. I will create that notes only for you. So 2 classes, we will take 1 organic class and another inorganic. What's it?
Yes, ma'am, okay, ma'am.
Okay, and I just need to check that how much classes schedule are shown to be left. Give me a second, Imanch. Let me check it once. Today it's all the classes done only, Imanch.
Yes, ma'am.
The calendar, I can see the calendar is showing the last class today itself of Imanch, right? And Madhu class is left. I guess because right now I'm taking a 300 per hour to be the payout of a class.
Yes, ma'am.
You already discussed this with your mother? Imanch?
Ma'am, yes, ma'am. I will discuss with you.
Okay. Is there any problem with that?
Ma'am, no problem.
Okay. So tell me then how to manage it anyhow. For our class timing.
Ma'am, at any time it's okay for me.
Okay. Everything it's okay.
Yes, ma'am.
So from tomorrow itself, how can you pay the amount accordingly, Himansh?
Ma'am, I will ask and I will inform you.
Yes.
When I
Then okay.
Yes, ma'am.
Okay. Okay, each and every class, whatever I'm taking now, that is even beyond that as well. But I'm keeping that 300 for you for these classes. Okay.
Yes, ma'am.
Okay. Update me again. Okay.
Yes, ma'am. Okay.